Hello, my name is Nathan Eskew, project leader of the EIT Manufacturing 2023 FirstTimeRight proposal. We thought it would be best to make just a very short video to talk about some of the key points of our proposal, really addressing the problem it's meant to solve, what that solution actually looks like as a product, and how we plan to deploy it in order to maximize the economic benefit. So our problem is widespread. What we are looking at is the fact that our yields, especially with precision manufacturing, are not where they need to be. Especially in the field of any type of additive manufacturing, yield is a major concern, as is quality. Now the problem is, if you have the best quality control system, it's too late. By that point, you've already lost your yield. You know that what you have isn't good. But what would be better is to know, as you're producing the whatever you're manufacturing, to know this is good, this will result in a good quality, and if something is starting to go wrong, you want fair warning in order to fix that, thus ensuring high yield. And that's where our project comes together. Our solution is combining some of the work done by our industry partners already, some of the research being done by TU Delft, and some of the capabilities done by our IT partners within the group. We have a great team that has all the right skills. Our solution is essentially using multimodal sensing along with a trained AI neural network in order to accurately identify all process variation within a manufacturing process, in order to essentially say this product is being made the way it should be, or it's not. And here's what needs to happen. So our solution creates that in a way that is as easy as possible to implement in any manufacturing environment. So our team is TU Delft. Part of my team's research has been on process monitoring and process NDT, using AI techniques to enhance that and bring in more inputs to make it more accurate. Guaranteed, which is a high precision manufacturing company using KUKA robots to use metal additive manufacturing. They've been working on process monitoring as well. D-Cube, a company that supplies a ready-made solution for aluminum extrusion, where they can do inline NDT using AI very, very accurately. They want to get more into the process monitoring and combine that solution to make what our team is working toward. Then we have two top IT firms, CGI and Concept Reply, representing the Netherlands and Italy, and a lot of customers throughout Europe. They're able to take a solution like this that involves hardware, software, and the people to install and configure it correctly and make it work for their customers. And then our secret weapon is PBN, a network of hundreds and hundreds of SMEs throughout Hungary and beyond that are able to be our voice of the customer. They represent all of these SMEs with access to them. So as we're developing the solution, we know what's important to them, and we can design our product in a way that we know will not only sell, but create that exponential ROI for us and our customers. So with our team, we have very broad representation throughout Europe. 50% of our partners are from RIS countries. We have 3 different CLCs represented, and this wide distribution, not only geographically, but having a wide set of perspectives and customers, allow us to really create a European-wide solution. So the current research that we're doing, as I mentioned before, we are taking some precision manufacturing process. In fact, this is one of the robots we're using, and we're developing a sensor suite that can capture up to 100% of the process variation. Then we're taking that data, making it the training sets that we need, training that model, and then deploying it to where it can say, yes, this is going to be a quality product, or no, it's not. And for now, we're also using non-destructive testing techniques to then verify that and help create that training set. We're getting this process together, and understanding the fundamentals in a way that can be readily applied to manufacturing. So our product then looks fairly similar to this, and it brings in some of the experience done by our industry partners, where we have any type of precision manufacturing process. We have our sensor suite that can capture any number of items within the process itself. Then we're able to identify how much data needs to be captured in order to create a proper training set and then to train that model. Once we have that, though, we also have different edge type hardware such as TPUs, TensorFlow processing units, that are able to hold that model and on the side of the robot, without having to go to other servers or other large infrastructure, be able to identify that something is going right or going wrong and inform the process technician immediately so they know what to do. So our product components are a hardware package of different types of sensors, these multimodal sensors that can capture variation, a trained neural network in the form of software, and additional edge hardware that allows all of that process to take place where the manufacturing is happening. So with this, how is this going to be deployed? So over the 2 years, we have TU Delft as our research focusing partner, and with the rest of our teams, we've split it into 2 use cases. One, CGI is the IT partner, the other, Reply is the IT partner, and then we have Guaranteed, our metal additive manufacturing end user, but also a core partner on the team. They're going to develop this solution for their processes. Again, they've already developed some of what they need. They've learned quite a few lessons. So now we're going to create this product for their solution. On the other side, we have D-Cubed with their partner, our eventual end user, the aluminum extrusion companies, at least 1 or 2, that will be employing this and using it in combination with their current NDT system. Once we have those, our goal then, largely in that second year, is to evolve a generalized solution. We'll know what it takes to take any manufacturing process, what sensors will need to be in that package, and how best to quickly train and deploy that neural network so that our IT partners can go in, they can work with that company and install this product in a way that handles that manufacturing process. And then from there, with that generalized solution and working throughout with PBN on our large network of SMEs, we'll identify many of the different use cases they have and be able to ensure before we even release it that our generalized solution will work for at least the vast majority of these different use cases. Now, in terms of economic benefit, and this is somewhere that can be a little confusing because it's different from your traditional EIT proposal. Instead of having just a single business owner that then creates the economic benefit from this, our solution allows us to have a multi-stage ROI process. This is very risk averse and ensures that we get that ROI benefit from a number of our different partners, but it also allows for exponential expansion. And this is something that a lot of EIT proposals just don't have. They have linear expansion, not exponential. So this is where our solution is going to create much more benefit. So we have our 2 end users with our 3D additive manufacturing process, which can be represented with Guaranteed, but also companies like it. And then we have our aluminum extrusion, very different industry, realizing their own version of this solution. Then we have our generalized solution that can be expanded across Europe. We have any industry that has any type of precision manufacturing is dying to have this type of technology where they can monitor and control and ensure that their processes are doing what they are meant to do. So we have already charged up and ready our CGI and our Reply, who are going to own this product and sell it with PBN's network initially, and then all throughout Europe as it gains momentum. So we'll have access to all of those different partners with PBN, hundreds and hundreds of SMEs that will benefit from this. And then from there, part of this product is ensuring, using data, using metrics, that the solution will generate an economic growth for that end user. that will guarantee that if we increase the yield by even 5–10%, that your revenues will more than make up for the cost of installing this product. And this product can be installed on any number of processes within a single company as well. So we're able to pinpoint their highest levels of attrition and the cost that it causes and find that greatest economic impact. So at the end of the day, we have the basis for immediate economic growth, but then we also have the basis for expanding this to a number of different industries and many different manufacturing organizations across Europe, which will increase Europe's ability to have precision manufacturing and increase its ability to become a leader in the global market. Now, the great part about this is everything that we are going to do is the foundation of your smart factory. Being able to start this digital thread with process monitoring allows us to have automated control, human-machine teaming, getting to digital twins, which this essentially creates by using this process monitoring technique, but able to take that digital twin and do any number of things with it, including predictive maintenance, optimization, simulations, and even AR, VR manufacturing. And we have plans for all of that on the research side, so we're excited to get this section complete so we can then tackle those next steps, eventually leading to, ideally, a lights-out factory that knows it's making precision parts efficiently, effectively, and at low cost. Thank you.